This is the fourth video for chapter 3. This is exponential equations to any base. So let's get started here with some easy examples. In the logs video I did previously, and from work you've done in previous years, you know how to change from log form to index form. Okay, so an easy equation like this, we start by converting this to index form. So 2 to the power of 3 equals x. Okay, equals 2 to the power of 3, therefore x equals 8. Fairly straightforward. Next one, similar sort of thing as the last one, except we've got some other steps here that we need to do. I'm just going to remove the brackets here for a moment, because what we're going to have to do here is use the rule that says if we've got that index there of 4, it can pop out the front and be a coefficient here of the log x to the base 3. There it is, equals negative 16. Once it's out there as a coefficient, I can then divide through the right hand side by 4. So log x to the base 3 becomes negative 4. So I've divided the right hand side by negative 4. Then convert to index form. So 3 to the power of negative 4 equals x. 3 to the power of negative 4 equals x. X equals 1 over 3 to the power of 4. X equals 1 on 81. And we're done. Next one here. So straight away out of log form to index form. 5 to the power of 2 equals x minus 1. 25 equals x minus 1. Take the negative 1 across. X would equal 25 plus 1, which is 26. Next question. Out of log form to index form, x squared equals 4. X squared minus 4 equals 0. Okay, you could also do there x equals the square root of 4. Same thing. But if you do it this way, it's difference of perfect squares now. X minus 2, x plus 2 equals 0. X equals plus or minus 2. Same here. The riskiness of the right-hand track is that you've got to remember that the square root of 4 is not just 2. Okay, we've talked about that before in class. It's plus or minus 2. All right. Second example, we've got out of index form once again. Whoops. We've got x to the power of negative 3 equals 1 on 125. Now, of course, 1 on 125 equals 1 over 5 cubed, or 5 to the power of negative 3. Now, once you get to this stage, quite clearly see that x to the power of negative 3 equals 5 to the power of negative 3, then x must be equated to 5. Some more questions now. Once again, they all involve going from log form to index form. 2 to the power of x equals 16. 2 to the power of x equals 2 to the power of 4. X is quite obviously 4. Next one, 3 to the power of x equals 1 over 3. Very important that you recognise that 1 over 3 is 1 over 3 to the power of 1. Make that index, or take the positive 1 to the top, and we get 3 to the power of negative 1. So please remember that. That's a conversion that sometimes we forget. 1 over 3 is 3 to the power of negative 1. 1 over 10 is 10 to the power of negative 1. Once we get to there, quite obviously, x equals negative 1. Next one, 9 to the power of x equals 3. Alrighty, we've got two different bases here, 9 and 3. But we know that 9 is 3 squared. So 3 squared to the power of x equals 3 to the power of 1. Make that to the power of 1. So that means 3 to the power of 2x equals 3 to the power of 1. We've got 3 on both sides there now, so we can equate 2x to 1 and x equals 1 on 2. Alright, now to some harder stuff. And just realise the right hand side of this is missing, so all of that actually equals 3. What to do here? Alrighty, a few things we can look at doing here. First of all, we need to tidy up this left hand side by using our log rules. Now we've got base 2 there, there and there, so we can use our log rule that says when we're adding those expressions we can multiply the 4 by the x. So we get 4x, and then we divide it by the subtracted one. There's our subtraction sign there, so it's divided by 8. So when you add 2 log expressions with the same base, you can multiply. When you divide 2 log expressions with, when you subtract 2 log expressions with the same base, you can divide, and that equals 3. You can tidy that up by saying that 4x over 8 is the same as, if we cancel the 4 and the 8, it's going to be x over 1x, or x over 2. Okay, equals 3. Out of log form now, 2 to the power of 3 equals x over 2. Switch those around, so x over 2 equals 2 cubed. X over 2 equals 2 cubed is 8. X equals 16. And we're done. Next question. A few ways of going about this. First thing I'd probably look at doing is tidying up the left hand side here. Log base 10, and we've got x multiplied by x take 3 equals log base 10, and we've got 4 there. Once we've got expressions with base 10 on both sides, and I'll put an orange square in this, so we've got log 10 on that, log base 10 on that side, log base 10 on that side, and just really pointing out here there has to be only 1 on each side, not, and I'll show you something else in a minute, but 1 on each side. You can actually then drop the log base 10 out, so we then get this. Now we couldn't do that from the start. You might think, well, why didn't you just drop them all out from the start? Okay, when you've got the situation, I'll do a different coloured square here, so you can see we can't do it when we've got a situation where we've got 2 log expressions on one side and 1 on the other. We can't do it then. We can only drop them out when we get 1 log expression on one side and the other side will have to be the same log expression, both base 10. From here, okay, hopefully we realised that we would expand the brackets. Then we create ourselves a quadratic by taking the positive 4 over to the left hand side. Okay, so x minus 4, x plus 1 equals 0. Therefore, x equals 4 or x equals negative 1. Right, this brings me to something very important. Okay, looking at this expression over here, part of the question was log 10 to the base x. You cannot not have a negative number up here for x. Okay, so you look there, one of our solutions was x equals 1. We cannot have a negative number there. So, in actual fact, we only have one solution, and that's x equals 4. Okay, if a solution there creates a negative anywhere in our expressions, here or here, oops, or here, then that is not a viable solution. So x equals 4 is our only solution there. Okay, so there's some log equations. Hope that gets you started. You should now be able to do exercise 3D on page 143.